Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and good morning to fellow panels. I am Muhammad Izzat bin Saleh from BMMH. My metric number is B0919102257 and my supervisor is TS Dr. Umar Al-Amani bin Haji Aslan. Now, my presentation is about a study of porous ceramics with different polypropylene contents for low thermal conductivity applications. Okay, let's continue on the background. The thermal comfort is crucial for humans, so we are able to deliver a greater performance on our daily tasks or work. As you can see in the slide, there is a figure that is related to human comfort. The first one is the humidity, next is the air speed, third, the air temperature, fourth, radiant temperature, the fifth one is the metabolic rate, and the last one is clothing insulation. Ceramic tiles can be found anywhere inside the building or even outdoor. The pores exist in tiles because of pore forming agent added in the ceramic tiles mixes, and it will be removed during the sintering process. Okay, now let's continue on the problem statement. There is a few thermal properties that affect thermal performance, which are heat capacity, thermal expansion coefficient, and thermal conductivity. As the number of pores increases, the mechanical strength of the ceramic will be decreased. Pore forming agent is added to a certain level of content, so it will not reduce ceramic tile strength. As you can see, on the right part of the slide, there is a picture of the porous ceramic tiles using the scanning electron microscope. There is only two objectives to achieve at the end of this research. So for the first one is to fabricate the ceramic samples with various contents of polypropylene or PP. Then for the next one is to characterize the mechanical properties of ceramic samples. Now for the literature review. Here is the raw materials for porous ceramic samples. There are 4 materials that we are going to use to make the samples, which is the first one is clay, next one is feldspar, third one is silica, and the last one is our pore forming agent PFA, which is polypropylene. Now the clay is a fine grained earth that is hard and sticky and can be shaped when wet. It is dried and baked to make bricks, pottery, and ceramics. For feldspar, a common material that form rocks, it is made up of aluminosilicates and potassiums, sodium, and calciums, and usually form crystals that are colorless or pale. The next one is silica. Silica is the term for a group of minerals that are mostly made up of silicon and oxygen, which are 2 most common elements in the earth crust. And now for the last materials that we are going to use to make our ceramic sample, which is our PFA, polypropylene or PP. Polypropylene, which is also called as polypropylene, is a thermoplastic polymer that is used in many different ways. It is made from the monomer propylene through a process called chain growth polymerization. The advantages of polypropylene as pore forming agent are low price and available in huge quantities. The other advantages include superior processability, mechanical qualities, excellent chemical stability, and thermal stability. Here are a few examples of sources that included in this research, which is from articles or journal. The first one is Makarimi in 2012. He wrote about individuals' autothermal perceptions. Then Lee in 2022, examples of the pore-forming substances. Dye in 2015, elimination of PFA to form the porous membrane. And the last one is methane in 2004, PFS application in ceramic technologies. For methodology, design of experimental. Here, as you can see in this slide, there is a flowchart of preparation and fabrication of ceramic samples. First thing that we are going to do is collecting all of the raw material, which consists of clay, feldspar, silica, and pore-forming agent, which is polypropylene. The polypropylene will be added at a certain level of content, which are 0, 3, 5, and 10 wattage. Next, continue on the wetting process, where each material will be wet accordingly. After the wetting process complete, we continue on the mixing process, where the mixing process will undergo for 3 hours long for each level of content. After the mixing process, we continue on the sieving process, where the sieving apparatus will be used at 60 micrometers. After the sieving process complete, we will be continue on the sintering process, where we will bake the ceramic samples at 1075 degrees Celsius for 3 hours long. And the last one for the process of this research is testing and measurement. Here is the table for the weight of raw materials powder. For clay, the weight is 24.84 grams, feldspar 40.64 grams, silica 4.51 gram, sodium silicate is at 5 gram, and for the polypropylene at 0% is 0 gram, 3% is at 2.1 gram, 5% is at 3.5 gram, and for 10% is at 7 gram. Here are the list of tests and analysis methods that we are going to use in our research. The first method is X-ray diffraction or XRD, which to examine crystalline structure. Next, scanning electron microscope or SEM, which is to observe microstructure. The third one is 3-point bending strength test, is to determine the bending strength of the ceramic samples. And the fourth one is A&D FC 300i DC precision balance, is to calculate apparent porosity and density. And the last one is thermal conductivity machine, is to determine the thermal conductivity of our ceramic samples. For the last part of this presentation, where I will present about the result and discussion. The first one is higher percentage of polypropylene in the sample produce more porosity. Due to lower percentage of polypropylene in the sample, the bending test result is better. As the percentage of polypropylene decrease, the density of the sample is increased. And the last one is the thermal conductivity on higher percentage of polypropylene in the sample has a lower result. Take note where the result will be finalized in the PSM2, where all of the experiment is conducted. That's all for me. Thank you.